Okay, so this is a 2018 Matrices question. It's question 4. It says a shear of the XY plane maps the points 1, 1 and 3, 2 to the points -1, -5 and -4, -19 respectively. So we set that up and it says find the matrix which defines this transformation. So that's part 1. So some matrix, we're calling it A, B, C, D. If you multiply it by the point 1, 1, it gives you -1, -5. And if you A, B, C, D, multiply it by the point B2, it gives you the point -4, -19. Multiplying this out, then we're going to have A plus B equals -1. We are going to have C plus D equals -5. Over here we are going to have 3A plus 2B equals -4, and we're going to have 3C plus 2D equals -19. If you take these two equations here and you take these two equations here, I'm going to go out on a limb and suggest that if you're doing ASfurther maths, you know how to solve two equations, two unknowns from year 10, but the values that you get are A is -2, B is 1, C is -9, and D is 4. So the matrix that we require then is -2, 1, -9, 4. We need it for part 2, so I'll cheat there a little bit and write that there. Part 2 says the transformation has an invariant line which passes through the origin. Find the equation of this invariant line. So if it has an invariant line, then there's some line x and mx, it goes through the origin, so it's to the form mx, and that's going to go to some other point t and mt. Remember, an invariant line doesn't necessarily each point go to the same point, but it goes to another point that's on that line, hence we need to write it like that. Multiplying this out then, -2x plus mx equals t, and -9x plus 4mx equals mt. A couple of ways to proceed from here. The way I would tend to do it is I'm going to substitute this t for this here. So my next line is -9x plus 4mx equals m upon -2x plus mx, -9x plus 4mx equals -2 mx plus m squared x. You'll notice then that the x's are going to cancel, so we have that, and if we rearrange this all, we should get m squared -6m over this side plus 9 equals 0. Factorizing that, we're going to get m minus 3 and m minus 3 equals 0. That gives us then m equals 3. So the equation of our invariant line is obviously then, sorry, we'll run a space here, y equals 3x. On to part B then, describe the transformation given by the matrix. I'll not spend too long on this one. -1/2 √3 over 2 minus √3 over 2 -1/2. I would hope that you recognize those as being trig ratios. So if you muck around with it, you will hopefully see that is going to be a rotation of 240 degrees anti-clockwise. Again, if you look up your formula booklet, it gives you that, and you can see then that the angle is going to be 240 degrees. So it's 240 degrees anti-clockwise about the origin. The final wee part, sorry, that was part B. That was part 1 of that, and part 2 then says find the smallest positive integer n such that a to the n equals I, where I is the identity matrix. Bit of a strange question, this one. It's a wee bit like kind of group stuff from a few years ago. But if it's rotating around 240 degrees, how many times it would have to go round to get back to the origin effectively? So if you go to 240 and you times it by 2, then you would get the 480. If you times it by 2 again, it'll be 720. So that's around 2 times. So that means the power then is going to be 3. So it represents how many of these are going to give you a multiple of 360 effectively. So 3 of those give you 720. So the value then of n must equal 3.